So no storage limits, just reach for the sky with data virtualization in SQL MI. Almost sounds like a song, like I swear I can almost hear the tune, and I have my Madonna mic, but I will not try to sing, not enough confidence for that. So like the proper title for the session would be something like Data Virtualization in Azure SQL Managed Instance. That's very, very formal. So welcome, thanks for coming. My name is Sasha Popovic, and I have Nico Neugebauer, my colleague, with me here, so he might help with some tough questions or something. I'm Sasha, product manager in Azure SQL Managed Instance team. I've started with SQL team 12 years ago, worked on window functions and query store back in the time. Maybe you are familiar with those. And for the last 2 years, I'm in the product manager role. We used to call it earlier pro. So now we have renamed to product manager. So feel free to find me on Twitter, on LinkedIn. I also blog on tech community, so feel free to find me there and reach out. So today we are going to talk about why doing data virtualization in the first place. Why not Polybase? Some may heard of that, so why not Polybase? So how to use data virtualization? What about perf? In the end, I will talk a bit about the roadmap for the feature, and we will have Q&A. But you can also ask questions. I will try to address most of them during the session, but we'll see how it goes with the timeline and everything. But before we deep dive into the data virtualization topic, because we are talking about this from the managed instance point of view, Azure SQL Managed Instance, I want to clarify briefly what is Azure SQL and what is specifically Azure SQL Managed Instance. So Azure SQL is family of SQL Server-based products in the cloud, and it consists of several products. Azure SQL Managed Instance is platform as a service product that is best for migrating your workloads from SQL Server, then modernizing and developing further. So what does it mean, platform as a service and managed service? That means that hardware, operating system, SQL Server bits, we are in charge of maintaining that and running upgrades. And all of that maintenance and upgrades are happening online. So if with SQL Server you are installing cumulative updates or you need to install security patch, critical security patch and OS, so with Azure SQL Managed Instance you don't need to think about any of that. It all happens in the background and with no downtime. In addition to that, we out of the box, as soon as you provision Managed Instance, you have 4 nines of SLA. That is industry-leading number. You don't get that with any of the competition. In addition to that, we run backups of your database, and at any point you can do point-in-time restore of your database to your managed instance or another managed instance. So it's a nice package. So how does that compare to other products? So with SQL Server on virtual machines, you're in charge of the upgrades. You need to establish high availability. It is your responsibility, and you need to take care of backups. So on VMs, you don't have a lot of these interesting goodies that we have on PaaS. Azure SQL Database, on the other hand, unlike Managed Instance, which is managed SQL Server in cloud, you can think of SQL Database as of managed single database in the cloud. So it is PaaS, it has automatic upgrades, high availability backups, but it lacks surface area that is not related to single database. So think of SQL agent, transactional replication, CLR, distributed transaction, service broker. So all of those things that you might be using on SQL Server, they're available on Azure SQL Managed Instance. They're not available in Azure SQL Database. Azure SQL Database has other advantages, such as hyperscale. Any questions here? Okay, we're all good. We know what is Azure SQL Managed Instance, so we go into the topic that was promised. So why doing data virtualization in the first place? So we all try to run businesses and run data-driven decisions for our businesses. And I would say that nowadays it is getting more and more easy to collect the data from various sources. So maybe you have telemetry from your system, maybe you have IoT that is sending signals, maybe you have data here and there, and getting all that together, mixing all that data, trying to make sense out of all of it, and turning all those signals into information that later you can act on, it is a challenge with more and more data. So being data-driven is complex, and you may try to have a 360-degree view of your data. Maybe at some points you succeed, but then new data sets might appear. And then maybe you want to do agile experimentation. You want to just take a look what's in there, but you have to run ETL to insert the data in the database. And at that moment, it is maybe not that agile anymore. So with these topics and these ideas, data virtualization can be very useful. What is data virtualization? So all of your data sources that might land the data onto some relatively cheap external storage in certain formats, if you can get your data there, then from Azure SQL Managed Instance, you will be able to access that data as if it was local in your managed instance. So today, we support Azure Blob Storage and Azure Data Lake Storage Gen 2. And we support CSV, Parquet, JSON formats. And that data in the managed instance will be available through external tables, views, or open row set. What are the typical use cases? So maybe you are approaching storage limits of your managed instance, and you would like to offload part of that data to an archive, but you are not ready to put it somewhere in the basement because maybe you will need the data. So you can offload your cold data to external storage through data virtualization, and you are still able to have read access on it, and at the same time, if you delete it from the managed instance, you release the pressure from the data storage. So on SQL Managed Instance today, we have a limit of 16 terabytes. It is quite a lot for a managed service, but you might have more data, and if the data is, if the good portion is kind of cold, you can go with this. Data exploration is another scenario. So a new data set appears, you don't want to ETL and insert it in your database, you just want to connect to the data and see if there is anything useful for you there. And then if there is, you can figure out later how you want to use it. Relational abstraction, so all of your external data sets and all of your local data, you can mix it in your queries, so you can join the data, run any kind of analysis, you can slice and dice the data, so it's from a convenience point of view, it is very, very useful. Single source of truth, so you may have multiple data sets, and you may have multiple personas that want to use those data sets. So instead of maybe having to copy the data sets for various use cases, you can have all of them connect through Azure SQL Managed Instance and access the single copy of external data, so everybody works on the single source of truth. And finally, this is a little bit of the anti-pattern, remote data input. So if you, in the end, figure out that you want to insert data from external data set, you can very simply do select from external database into local table, and move the data into the database. So is this Polybase? It sounds kind of similar. This is not Polybase, this is evolution of Polybase. So we built this on top of Polybase technology, but with upgraded experience. So first of all, this is platform as a service. So unlike Polybase, you don't need to install anything. So everything comes pre-configured. You create managed instance and you can use data virtualization. Architecture behind it is modular. So we can relatively easily provide support for additional storage types and for additional data formats. You have better performance with this. We have predicate pushdown, partition elimination. We will talk about this a bit later. And we are shipping this in Azure SQL Managed Instance, but also in Synapse Serverless and SQL 22. So we have the same technology in several products that we are releasing. So I will show a few demos. I don't feel like fighting the demo gorgons. So I will show pre-recorded demos so that we can focus on functionality and explaining what can be done there. So first demo will be on data exploration. We will use two data sets. One is the Bing's Open COVID data set, and one is our company's proprietary classified data set on sales. So in this demo, we are pretending that we are running a company that is selling pharmaceutical products, and then we will want to do some kind of analysis on the archived sales data. So let's take a look at the first demo. Any questions maybe before we start? Okay, no questions, so let me start this. So in this demo, we are using Bing dataset. Bing is hosting this on Azure storage in different formats, and we will use Parquet format in our demo. So we will copy this path later. We are using storage account for storing our classified data. It is data virtualization demo 11. And we have several containers here, and we will use our sales demo container. So in this container, we have daily sales archive and archive partitioned. Same data in two a bit different formats. And we are using our managed instance MIFOGE. What a name, who names these things? We will use sales data demo database in the demo. So without further ado, we go to SSMS. This is our connection to our managed instance. We are connected to our sales data demo database. And we will take part of the data set from the COVID documentation. We will rearrange it a bit. So instead of HTTPS, we put ABS as in Azure Blob Storage. Then we put container name at fully qualified domain name of the Azure Blob Storage, and then the rest of the path towards the data that we want to query. And just like that, we run select top 1000 from open row set. And that will give us data. We have predicate where country equals United Kingdom. So let's run the query. In a few seconds, depending on the data size, remote storage type, network connectivity, after a while, you get the data. And notice this was convenient from 2 points of view. So we didn't have to specify schema. So we don't know column names. We don't know data types. We just put their path to our data, and we got the data. And We didn't also have to run any ETL, so data is still there on the Azure Remote Storage, and we're just querying the copy that is sitting there. And once we get the data, we have opportunity to investigate the data, to see what are the values, what columns we have there, what are the data types, to see if what we have there maybe makes some sense for us or not. And not only we can explore, we can run more complex queries. So we can, here we will run some of confirmed COVID cases per country for the month of June of 2020. This could be a report that runs on top of your external data. Just like that, again, we get the results. We didn't have to know what the schema is. We didn't have to know. We didn't have to specify the schema nor to import the data. Yeah, just a moment. Let me pause this. So I don't have benchmarks to repeat the question. So what is the performance impact? So if you have 100 million rows on remote storage and compared to local storage. So I don't have benchmarks that I can share. It also depends. It depends on the managed instance SKU. It depends on the SKU of the remote storage network between them. So anyhow, it would be useful, like if you want to do this, it would be useful that on your specific case and your specific setup that you run some kind of testing to see if the performance is good for you. Definitely it is slower because data is remote, but this is more about the convenience of accessing the data than about the speed. Nico?
Just if you are running a general purpose service tier, managed instance, your storage is remote. So the change from the remote storage of managed instance to, let's say, blob storage or ADLS, Azure Data Lake Storage, which hosts this data, it will be visible. It's difficult to predict the exact number. It will be visible but tolerable. Your users might not notice. If you're running business critical service tier, you're using fast locally attached SSD, the latency will be absolutely different. Cold data, not frequently accessed data is perfect for that. If you want an OLTP scenario to use that data, try to test it.
Yeah. I've got a question along the same sort of
Yeah,
lines.
go ahead.
Parquet is relatively quick, and you were saying as part of your demo there, one of the great features about it, going in that public data remotely, is you didn't have to define the schema. But when we get to much larger amounts of data, that's going to be a problem, right? As soon as you get large amounts of Parquet, no schema defined, it's going to be quite slow and sluggish. Is there any
I agree, and we will get to that. So you can define schema. I'm just saying, like, if you're in the stages of early exploration, you don't need to. So it's a convenience, but then later you will probably want to do it.
Sorry, I jumped the gun.
No, that's completely fine. Any more questions? No, okay. Let's continue. So we will now switch to our data, so not open data. We have partition data per year and per month, and it's nicely named like month equals something. And in each month, we have Parquet file with the actual data for that month. So this is how our partitioned external data looks like. And we can take a look at non-partition data. So here we have flat structure, so only one Parquet file with the entire archive. We will copy these URL of of this data, and we will take it to SSMS. Again, we will need to massage it a little bit, so HTTPS replacing with ABS, then container name at fully qualified domain name of the storage, and then path to the query. And we run select top 10 to see what the data looks like. And again, just like that, we are getting the data and we can explore it. So this is not open data set. This is our classified data. And I have been able to access this data only because authentication authorization with managed identity was already set up. So we support SAS tokens, but those are less secure because you work with the secrets. You can copy the secret in the wrong IM somewhere, like, or save it in plain text. I hope you don't do that. But it happens from time to time. So with managed identities, you never work with the secret. You just take managed identity of one Azure resource and you say, oh, this resource will have access to that one. So it's very convenient and safe. For managed instance, we go on the portal to identity section, and we just enable, we say we want to have system assigned managed identity for managed instance, and you have managed identity for this resource. And then when you want to grant access to the remote storage, you go into remote storage access control, and you add a new role assignment. This is already done. So I will go to check that my managed instance is already there. So in role assignments, I search for MI FOGE, and I see indeed that managed instance is there and that it has storage blob data contributor role, meaning that it can write to storage, it can also read from the storage. So that was the first demo. We have explored our company's data. We have explored Bing's open data set. A few more things to notice. So we have been using this syntax to query. This is how we can create managed identity and create external data source and query from data source and specify paths that we want to query. But we don't necessarily need to use this syntax. We can create external table with external data source, or we can create view from open row set, and then we can query our external data the same way. So on T-SQL level, it looks the same as if we are querying tables and views. So what about perf? So what are the things that you can consider to make your queries with remote data more performant? So there is schema. We will talk about that. But also predicate pushdown and partition elimination. Those are two techniques that are implemented and are working. So we will see this in action. So I will start with trying to calculate min and max confirmed cases per region, subdivision, region. From my public open data set on COVID, 4-country region, United Kingdom, grouped by these categories. So this query will run in about 5 seconds. You can trust my word. So if we want to specify the schema, we can use SP describe first result set store procedure from top few rows, and there we will get column names and data types, and we can embed those into the query. The store procedure for all strings, it will return us varchar 8K, and in reality, very frequently our columns will not be 8K, they will be shorter. So another thing we can do, we can determine actual months length of our strings. So we combine data types and proper string lengths to get faster query. I will start next demo.
Sorry, the name of the stored procedure where you define the data type.
Yeah, SP describe first result set.
And this will be a copy of this presentation available.
Yes, yes. You will get it through the SQL bits. If not, we will think a way to deliver it.
That store procedure is available in SQL Server 2012 and later.
Yeah. So it's not a new thing. It's just convenience. Like you don't have to figure out values in some other way. So original query was 5 seconds. That's on me. And then once we have the proper string lengths and defined schema of what we query, we will get faster queries. So I believe it is there somewhere around 3 seconds. I have a better screen here. Yeah. So can we make it even faster? Yes, we can. And how do I know? Well, because I worked on the demo. But jokes aside, let's take a look at the query plan for this to see what was the number of rows that this query worked on. So I enable query plan in SSMS. I execute the query. And when I get the results, I also get execution plan. So I see that in my remote scan, costs of this part is 100%. So everything is happening here perf-wise. So it makes sense that I try to optimize this part. So I take a look at the number of rows that the query worked with, and I see it was 4.7 million. So is it a lot? Is it not a lot? I'm not sure. Let's try to compare this number to something. So I will run count star on my entire data set to see how many rows do I have in the first place. And I have 4.7 million. So my previous query scanned through entire external data set. Although I was asking only for rows related to United Kingdom. And I have 23K of those rows. So is there something that I can do about this? Can I leverage this difference in volume of data? And the answer is yes, there is. I can utilize predicate pushdown, so this where clause from managed instance can go all the way to the remote storage and Parquet file. But in order for us to have predicate pushdown on string, on varchar columns, we need to use one specific collation, and that is Latin 1 general 100 bin 2 UTF-8. This is the collation that that Parquet works with and can understand, and with this collation, Parquet can do predicate pushdown. So once we specify the collation, our country region equals United Kingdom filter, we'll go to Parquet. Parquet will filter everything for us, and to manage instance, only United Kingdom rows will arrive. So let's run this query and see what performance impact do we get. So yeah, from 3 seconds, we go down to 0 seconds. So this was instant, and no wonder it was instant, because we know that that we have reduced number of rows that we work with. So here we see that now we work with 24K of rows. So that correlates. That's the number of UK rows that we have in the data set. Very powerful thing. So you want to be aware of how you use predicates to be sure that predicate pushdown is happening for optimal performance. Another thing I will show is our file functions. This has both functional value but also performance value. So we will now query our partition data, and we will use wildcards. Let's just remind ourselves of how partition data looks like. So we have there oh, this guy was so slow. So we have there data partition per year. Year equals something. That's what the name of each folder. And then in the next level of subfolders, we have month equals something. So we have a well-known structure, and we will use it in our queries. We go back to SSMS. And our first, okay, let's see the results. And we will see that our file path 1, that is our first wildcard, matched with year equals something. Then file path 2 matched with the second wildcard, and that was month equals something. And then our third wildcard matched with the file name without extension, because we specified extension here. Then next, we can call a file name function without parameters. This will return entire file name with extension. And we can look for file path, which will return entire file path from HTTPS all the way to extension, in this case, parquet. So this is very useful, because when you get your rows from external data, you can see from which file it came from which path it came from, so maybe that's important to you. We can use file paths in where clauses, and when we do that, in this particular case, remote storage and parquet, they will know to return only data from partitions that are related to 2019, file path 1 2019, so this is this part. So only from year 2019 we will get our rows. Before we run this query, we will again compare a number of rows. It will be there in a second. So we will take a look at the execution plan of the previous query. So previous query had no filters, and we will see that previous query worked with 40K of rows. So this is entire data set. Now, when we use where clause on file path and we activate partition elimination, we get only data from 2019, and if we look at the plan, we see that actual number of rows was 5K. So we indeed worked with a lots smaller data set, and this is indication that partition elimination was activated. You can also monitor this, like if you activate X event session and monitor X events, when we run external queries, we will shoot events that say, this is a query on external data, oh, and by the way, partition elimination is happening for this one, so you're good. Let me just pause this one or see what will happen next. But I think, so just to finalize, so file paths are first-class citizens in query. So not only you can use them in where clauses, but you can use them in group by to run aggregations, slice and dice. So you can use them as regular columns. And here we will run aggregation of total sales per category for June of 2019. So file functions, first-class citizens in T-SQL. There was a question, yes? For CSV files, this is not available. This is available for Parquet because Parquet has this functionality. I believe this is available for some other popular data formats that we still don't yet support, but plan to support. So you will have more of this in the future.
Just then, if you are talking JSON and CSV are the two other formats that we support, how do you filter on JSON and CSV while Parquet is a columnar with a raw view.
The block storage is filtered in the folders, the same way that you
Oh, so you mean the
year and the month, you can still have CSV files.
partition elimination on the CSV files? I am unsure.
I'm also unsure. So
I expect it to work.
yeah, so we can follow up afterwards. That one could be working. Okay, we go to the next bit. Was there another question? Sorry. Yeah.
Does this support Delta for the open rate set format?
Delta, not yet. So that is one of the things. Yeah, question was, do we support Delta format? So not yet. We are looking into providing support for that. We would really like to do that because we know it's popular and useful. It's not yet supported. Was that a note for 30 minutes? Aha, thanks. Okay, so this is a reminder for predicate pushdown. Some filter types are supported, so between filter type is not supported, so you need to rework it. In list filter is not supported, so you need to rewrite it a bit. A lot of data types are supported, some are not. This again all goes to what we can do with Parquet. So you can find this in the official documentation, and this is just for you to be aware that you might want to be mindful about data types and how you write your filters in order to get performance benefits. So next demo is about how you can mix and match your remote data with your local data and maybe show it through Power BI report. So let's run that one. So, just a moment, something has happened here. Okay. I apologize for the hiccup. I'm missing a couple of slides in this. Okay. So I have my Power BI report. I've inserted. I have data from Bing COVID data set and from Daily Sales Archive. And I've plotted this because I want to analyze for certain data period and for a category ID too. I want to analyze some. I have info that there is a drop in sales, so I want to figure out whether it has something to do with this. So I figure out. So this is one COVID spike, and I see when this happened, it correlated with a huge spike in sales for category 2. Then when another one was there, I had. Smaller spike, and then when third one happened, there was no correlation anymore. So sale of these products was not happening anymore. So this enables me to have some kind of conclusions. So I know that this is not a drop in sales, that this is some correlation in events that over time disappeared. That's maybe how people work sometimes. They change their behavior. But I'm wondering if the category ID 2 that I see here, like someone asked me, but what is category ID 2? And I don't know, I always forget. So I don't have categories in my external data sets. I only have category ID. So in order to display also categories in their string formats, I need to go to my local data and bring it somehow into this data set. So this was my query with external data, and now I want to join it with my local table categories on category ID. So I will take this query and take it to the Power BI. I will modify the data source there. I will, in the source, I will click on the little button and paste the new version of the query here with the join. And when I click OK, in a bit, this will refresh. I will apply, and data will be refreshed. So now, with this new data from my local database, I will be able to add another slicer here to the visualization. I will drag and drop my categories here, and already I see that 2 corresponds to anti-inflammatory products. So I just make it a bit nicer here, and I can now slice and dice this report through categories. I have joined my 2 remote data sets and 1 local table in order to create this report that was important for me. Any questions at this point? 10 minutes. Thank you. So, roadmap. So, we have released this in GA recently, and we are very keen on keep improving this. So we already have some plans for the improvements, but if you have feedback on the missing features, feel free to go to AKMS MI feedback. You can propose new features and ask and vote up for the already proposed ones. We do listen to your feedback, so I can tell you that end of 2020, 9 out of top 10 requested features were either delivered or in progress. So it makes sense to communicate through this channel. Every semester we review and we pull in some of the proposals into our execution plans. If you want to contact SQL MI team specifically, maybe to participate in a private preview of what is happening here, or maybe if you don't get the slides, you can contact us here so we can provide. So those 2 links will be useful. Maybe you want to take a photo of this screen in case you need it later. What is one of the next things that we are doing? So CTAS, create external table as select. This is still in private preview. You cannot use this today, but I'm allowed to say that this is coming soon. So with CTAS, what you can do with single query, you can select data and create it on external storage. And then once you do that, you may want to delete that data from your Azure SQL Managed Instance to free up space for some other data. So very quickly, how this looks like. It's like this. So we have create external table, name, width. So we specify location where we want this to be, data source and file format, and we can specify how we want to partition our data. So per year, per month, and then what data goes there, what is the result of this query. So we select a few columns and we define a year of sale date is year, month of sale date as month, from daily sales, where year less than 2023, because we want to offload and archive only data for previous years. Data for this year is very much hot, and we want to keep it in the local as local data. So we run this query. Again, depending on few things, service tier or managed instance, network setup, and then remote storage and service tier or remote storage, this can be slower or faster. But when this is finished, you have copy of your data there. So I will refresh my storage account, and my new data set appeared here. And now I probably want to run another query where I do delete from table where year less than 2023, and I have archived the data successfully. Official documentation and materials for data virtualization can be found on these links. You probably want to take a photo of this as well, might be useful. When it comes to Azure SQL Managed Instance in general, there is a question.
So just a question for the external tables.
Yeah.
That's only going to be supported for Arcade Files, right?
It's supported also for CSV and JSON. Yeah, and in the future, we hope that we will support more. I was showing Parquet because Parquet has most of these nice things related to perf, so it was the most valuable. Some other data types have that as well. So that's why I focused on Parquet, but you can query also CSV and JSON. Okay. In general, related to Azure SQL Managed Instance, I would advise if you plan to use or are using it, find us on YouTube. We have a bold plan of releasing about 100 videos in the next year, so you will find there a lot of how-tos, a lot of demos. It's a very convenient way to have that level 100 learning about the functionalities and about the service in general. I will again repeat, so this is how you can contact us, SQL MI product group, and if you want to request new features or upvote already requested features, MI feedback is the place for that. Any more questions? Yeah.
The first one is, the MI compared to Azure SQL DB is the same that you showed here, available on Azure SQL DB?
It is not. So this was released for Azure SQL Managed Instance and Sign Up Serverless and SQL Server 22. SQL DB does not have support for this.
And the next one is, when do you want to choose the MI compared to Azure SQL DB for smaller companies?
Yeah.
The price range and so on?
Yeah. The question is for small companies, when you compare SQL DB and SQL MI, there is significant price difference. So when do we suggest? So there is a good reason. We had 2 days ago a day with SQL MI, so we talked about this. So with the managed instance, you have single tenant environment. So nodes that are hosting your machines are just your nodes. So there is no multi-tenancy, and this is for the purpose of ultimate security. We also do this for the virtual from the virtual network point of view. This architecture does not let us easily to sell one core managed instances or half core managed instances. We want to get there, but it will take some time. So currently we have 4 core managed instance, and it is more expensive than 1 core SQL database. But if you compare 4 core managed instance in database, it is very comparable, if not identical.
I would like somebody to point me directly to the difference between 4 CPU SQL DB and 4 CPU vCore SQL MI.
Right.
I'm waiting for quite some time to be impressed.
And from functional point of view, the main difference is if you want to use the full surface area of SQL Server, so SQL agent, transactional application, linked servers, CLR. If you need all of that, managed instance is the place for you. If you don't need all of that, then SQL DB might as well be very well suited for you. Any more questions? Okay. let me just wrap up, and we can, because we are out of time. So thank you. My name was Sasha Popovic. Feel free to find me on Twitter, LinkedIn. Don't be a stranger. We'll be here for a few more days, so we can chat outside or later in the hallway or somewhere. Please provide feedback for this session. This is very important for me and for SQL Bits. I want to know how this was. Was it useful? So be honest, I can take it. That's all for today. Thank you. We can do that question offline. I would like to get off the stage to let the next person prepare for their presentation. Thanks a lot.